of experience with CAD software and related products. My expertise also extends to technical training and support. Today, I am joined by our distinguished speakers, Mr. Shabbir Lokhandwala, Managing Director and Founder of Slabs Engineering Private Limited, and our competition partner from Ethos Empowers, Mrs. Kanchan Nayak, Program Manager for Competitions and Events. I warmly welcome you both to today's design lecture webinar. And moving forward, Archons India is India's top technology provider for design and construction. We leverage data-driven solutions to improve projects, outcomes, and deliver value to clients worldwide. Our mission is to guide companies from concept to completion with our comprehensive tech offerings. Globally, Archons leads in adoption of CAD solutions and integrated workflows. With 50 plus offices across 18 plus countries, we support 32 languages, serves more than 40,000 customers, manage more than 4 lakh user licenses, and we have a team of 1,300 solution professionals. And we provide seamless round-the-clock support across time zones, setting a global benchmark in service excellence. This is all about us, and now I will hand over the session to Ms. Kanchan Nayak.
Thank you, Darshan. Hi, everyone. I am Kanchan from Ethos Empowers, and I'll just do a quick briefing of the Design Advanced 2024 competition for you. Yes. So, as you might already know, that Design Advance is a competition for students of architecture, planning, civil engineering, and design. And it is open for participation globally. This year, the theme is Architecture of Assembly, Industrialized Construction for High-Rise Buildings. This is the 4th edition of Design Advance, and we'll be discussing the theme, what your design task will be. We'll be seeing some quick case studies, and we'll move on to the competition and participation details. So the theme focuses on revolutionizing the construction process. And how does it revolutionize the construction process is through IC or industrialized construction. And we are particularly looking at prefabricated components and assembling those prefabricated components at the site. So it will help navigate challenges at the construction industry of site management, pollution that is done by the construction activities, unorganized labors, and workmanship issues and quality issues. So you might have already been living in residential high rises, or at least would have seen one. And you would have observed that there are repeating elements and identical layouts of units. So the staircases, the railings, the facades, balconies, toilets, even the rooms are stacked one on top of each other and exactly are duplicated one over each other. So in theory, it should be quite a simple process that the same object is being repeated everywhere, and the construction could happen quite fast and quite quickly. But due to the scale of the project and limitations of conventional construction process, these projects end up taking a lot of time to be completed and to be occupied by residents. So how is it that we can save time, effort, expenses, and resources while constructing these buildings? So that is where the industrialized construction comes into play. What happens is the foundation is laid using conventional methods of construction, and the superstructure components, they can be prefabricated at a factory and then transported to the site where they are assembled. So the process starts with making the standardized elements according to the requirements. Then the elements will be produced in a factory. Then the prefabricated components will be transported to the site, and the building elements will be assembled on site as per the design. What can be prefabricated? Building systems, complex elements that are there in a building, and the basic components like walls, floor panels, windows, kitchenettes, toilets, etc. They all can be prefabricated. Here is our first case study. It's called 10 Degrees and it's located in London, United Kingdom. So what you see here on the facade is this is just a blown up picture of that. And you can see the repeated origami-like shapes of these facade elements, like basically Juliet balconies. And on the next page, we see a close-up version of how these elements were created and then assembled. And this also shows the arrangement of units that could aid the process of prefabrication. So how did the process of prefabrication affect or like positively affect and benefit the construction process here? So the construction time of such a tall building that got reduced to a 39-month timeline from the concept sketch right to the handover. Then there was 67% reduction in carbon emission due to the construction, which is quite a large number. And the quality control was also much better and the finishes came out very much better. How did they do it? They extensively used techniques like virtual reality and 3D printing to create smaller prototypes and then looked at it like where they could modify something or where it needed some upgrades and then replicated the actual model into the actual building. And the prefabricated components, they were manufactured offsite and then assembled or stacked on top of each other at the site. The next case study is called the De Quakerage Apartments in Utrecht, Netherlands. And you can see the interesting facade that is going on here. And so what has been done in this project is that the kitchens, bathrooms, stairs, facade, these are the elements that were prefabricated and placed at the site. And it is a very highly standardized and rationalized design. So they had the ease of assembling it on the site later. Now we come to your design task. So your task would be to design a high-rise residential building or a building complex using industrialized construction with prefabricated building complex. How can you do that is by understanding what is IC and what is prefabrication of building components and how can you use them to create sustainable, accessible spaces and how much creativity that you can show while assembling these prefabricated parts of the building. You also have to explore some suitable construction materials and prefabricated components while designing your project. So with this method of construction, you will be able to demonstrate how a transition from unorganized to an organized construction practice, which will be unorganized construction practice would be the conventional methods of construction. But through industrialized construction, you'll also be able to explore how project management and well-organized labor force can aid the construction process, right? Then what you have to do in your project is to maximize the use of industrialized elements by standardizing the repeating elements. Like we saw a few slides before, that the elements like balconies or railings and doors, windows, even whole bathrooms, wall panels, etc., they can all be standardized and produced in a factory, and then it can all be assembled at the site. So here are the guidelines for choosing your site. So you choose an urban site, which is located in a tier 1 or tier 2 city with area between 5 to 12 acres. Minimum FAR that you should look at achieving is 3 and ensure that you have at least 15% of the site area as a green cover. You should follow the local bylaws or the National Building Code in case the local bylaws are not available to you. While making your sheets, ensure that 1 to 2 design sheets have the process and the types of prefabricated building components that are using detailed in them and why you chose them. Here are the things to consider while you're designing. Integrate the industrialized construction part in your design well. Do an in-depth research into IC and its application. Sustainability is not to be left as something to be added at the end. It should be a part of your design process. Ensure that the spaces are promoting well-being, and be as creative as possible while you are designing with prefabricated components. So here are the important dates, and the competition is open to all undergraduate and postgraduate students of architecture, planning, civil engineering, and design globally. And whoever has graduated or is graduating in 2024 is also welcome to participate in the competition. And per team, we will allow a maximum of 3 members. A quick uh, run through the frequently asked questions. Is there any registration fee for the competition or the workshops? Both are absolutely free, so please take advantage of both, because it's a competition that will allow you to compete with your global peers, and uh, it's absolutely free, and there are very few free competitions available for architecture and design students. Can postgraduate students take part in the competition? Yes, UG and PG students of architecture, design, civil engineering, and related fields can take part. Can team members in a team be from different colleges? Yes, inter-college teams as well as inter-batch teams are also allowed for the competition. In absence of local bylaws, which standard should be used? So you should use National Building Code in absence of locally applicable bylaws or site regulations. Can you choose a site on your own? Yes, absolutely. Just ensure that it is located in an urban site, um, in a tier 1 or tier 2 city, and the area should be between 5 to 12 acres. You should also be able to define your own area program according to what your site needs or what your program dictates. Lastly, make sure that you have registered for Design Advance at www.designadvance.in, or you can simply scan this QR code and register for the competition right now. Thank you.
Thank you, Miss Kanchan, for elaborating on competition. So this is our today's agenda. So introduction of archons is already done, and about design competition done by Miss Kanchan. It went well. So next one is our main design lecturing on quantification and scheduling in Revit, which is going to be taken by our speaker, Mr. Shabbir. So I will hand over session to Mr. Shabbir, and after that we'll be having an QA session where we'll be clearing the doubts. Okay, so I will hand over session to Mr. Shabbir.
Hello, good afternoon, everyone. So I would be taking you through a quick presentation wherein, I will be presenting to you the actual use of Revit in regards to the quantification estimates of BOQ, etc. Right? I hope, am I audible to you? Hello.
Yes, sir, you are audible.
Okay, fine, great. Okay, fine. So today I'll be taking you through live Revit models and the practical use of it and what we have been doing so far. So I think, like we are working in the field of precast technology and advanced construction technologies. And so a brief about us, basically. And some of the applications, like rightly, the theme is, just a minute, just a minute. Sorry, everyone. Actually, I'm a bit at site, so there's a lot of disturbance around. Fine. So a brief about us is we have been working in precast technology and advanced construction technologies. Our company is Slabs Engineering Private Limited, and we have been working in precast 3D printed concrete structures, parametric structures, and so on, 3D volumetric structures, and so on. So, uh, you know, basically, primarily, we have been doing the entire engineering, structural engineering, design, and modeling, and then finally extracting the drawings using Revit tool and software. So whatever you can see on the screen is like this is a mosque project, this is a public building, this is a school project in Kochi in Kerala, and then we have done Yenapoya University. It's a residential project about 1 lakh square feet, which was completed in about 4 months of time frame. So all these projects, we have done so far using BIM. Completely. We are entirely a BIM company, and we do all our projects, engineering projects, only using BIM. So the real-time advantages, you can see there's a modular structure. All the wall panels have been modeled, the slabs have been modeled, and then we extract the real-time data, from the Revit software. Okay. When I say that, let me show you like up to what extent we use it. Okay. So we create a virtual 3D model. It's entirely like a high-rise building about 10-story tall. And from this model, we are extracting every fabrication drawing. So for example, if I click here, right, this is my panel number A355. If I go to panel number A355, you can see the drawing sheet here. And we have generated, this is our formwork drawing, and this is our reinforcement drawing. So we have physically modeled each and every rebar. Okay. And then this is a bill of quantity. You can see the bar bending schedule, which is generated automatically using Revit. Okay. Which otherwise, a person would do it in AutoCAD and using manually and things like that, using some spreadsheet and then combination of AutoCAD and spreadsheet and things like that. So as an engineer who is doing competent, advanced buildings in construction industry, we require sophisticated tools to support our vision and the kind of projects that we do. So this is one such platform. I mean, there are tremendous amount of platforms. In BIM is a process and not a software, right? So I tell people usually that let's say in BIM, these are the kind of softwares available in the market. Okay. So for planning, there's a software, the design, there's a software, and BIM building, while constructing a building, there's a software, while operating the building, there's a software. So BIM is a process and not a software. Okay. So Revit is one such tool that we use very rigorously, okay, while doing our projects. And quantification or BOQ is just a part of it, right? So every time, so this is the level of BOQ in terms of rebar, pending schedule, etc. Now for every panel, there comes a volume and weight. Okay, so we have created some sort of soft scripts and things like that. There's a volume and weight of every panel is filled automatically. Okay, so there is no human intervention in terms of scheduling, in terms of quantification, etc. For all our projects. For all our projects, when I say it, I mean it because we are using it on day in, day out. Okay. So for example, if you see my building, right from the grout to my wall panels, to my slab panels, to my reinforcement, the entire, the quantity of the entire building material is taken out automatically. Presently, like we were doing one of our interiors projects, our own in-house, a new office project, and we what we did is we modeled the entire building, and we calculated the glass facade, the glass partition, the mullions, the doors, the windows, the entire areas, everything required for interiors as well, right? So this is a very beautiful software, and then I think this is where actually the value is added. Then a few of so this is how typically we get the output. We have created some sort of a template, and then we get let's say the number of elements in precast, the total quantity of concrete, the total quantity of steel. So we get for the entire project. So we understand the entire civil quantity of the entire project, right? Being an engineering firm, that is what where we need. Then when you see the entire 3D model, definitely like it gives you much more clarity, enhanced clarity and vision as to how your building will be constructed, erected at the site, reduces a lot of human intervention in terms of imagination, etc. Also, the BIM model gives you a lot of indirect advantages, like you can check the number of elements, you can check the tonnage of elements, if it can be really like lifted by the crane or so on and so forth. And then we also take out the entire drawings using the Revit software. Okay, so these are some of the indirect advantages or direct advantages that we take out of the software, right? So that's where we stand. Okay. So that was just a quick brief from my end about how advanced quantification and a tool that we are using to extract the information from the software. Let me show you one another example so that you get much more clarity as to how you can use this tool and software to what extent. So this example I'm showing you right now is a precast building. It's not like a conventional building. So in precast building, you have to literally model each and every joint. This is one panel, this is second panel. So if I go to the top view, you'll see each and every joint. So every panel is physically modeled in the software. Okay. Definitely a lot of SOPs, standard operating procedures, and a lot of inputs have gone through for us to arrive at this level, the kind of work that we're doing. But definitely the kind of competency we have developed for using BIM at a very advanced level in these last 10 years. Okay. Right. So this is one such sophisticated project in precast technology when I wanted to showcase you the kind of detailing that we do, the kind of quantification and the advantages you can take out of the software, and the benefits you can take out of the software. Now this is one such interiors project wherein we have modeled entire MEP. So in this project also in precast building we have modeled the complete MEP, mechanical, electrical, plumbing. So if you see here, you can see the glass partition. We have modeled the glass partition. We have modeled the steel work. Just a minute. Even we are doing some of the projects in 3D printed concrete structures. That also we are doing completely using BIM. Because I think that's it. I wanted to show from my end in regards to these projects. So here you can see that we have modeled a glass partition. We have modeled the mullions that's used for the glass partition. It has steel which is used for supporting the the glass partition. Then we have modeled also MEP, the conduits, the junction boxes, etc. The brickwork is modeled, RCC columns and beams are modeled. So it makes your life very easy, and then you get automatic BOQs from the software. which allows you to understand the exact estimates of the project in terms of the labor cost, in terms of the material cost, in terms of procurement. So the overall costing, what you allow for the project is exact. So the exactness of you're very very close to the exactness of the the quantification, etc. Right. So this is another project that I wanted to show it to you. Let me check if I have one more to show it to you. So over the period of time, we have done a lot of projects. Last year we have completed Kuwait International Airport, one of the largest airports being constructed in the world right now. Around $8 billion is the cost of the project, and the complete facade engineering was done by us in precast. So that's where we have explored. We have done parametric modeling for that particular building, and then we have also done GFRC design on BIM. A lot of facade engineering projects also we have done in precast using BIM. A dome-shaped projects also we have done when domes are casted in precast. So all such vague shapes also we have modeled in precast. This project I'm showing you here with a lot of architectural ornamental features. If you see this project, so all these features also we have modeled in BIM to understand the quantity of the ornamental features, which is having GFRC and backend it's having precast, etc. Right, so this also we have done it in precast. Right. Okay, so this is another project I want to show it to you. Okay. This is a project in Bahrain, wherein it's a multi-story building with a car park and so on, and completely in precast. So it comprises of columns, precast beams, precast hollow core slabs. So complete modeling is done, and then the entire BOQ, bill of quantity, etc. is extracted. If you see the schedules, you can extract it directly. Right click if I want to find out, you just click on material takeoff. If you just click on columns, click OK. So this is I think if I just click count, if I click on family type, material, area, volume. Okay. The volume. If I then also click on the level or something, yeah. Mark numbers also I can get from if I click on levels. Okay. Click OK. So I just click here. I think it's structural. Okay, so structural columns. Now to click on. Okay, material takeoff. Structural. Click on structural columns. You can see the entire BOQ that we get extracted from here. And if I want the total quantity of, let's say if I just click here, grand total, okay. So I'll get the total quantity of, my summation, the total number of columns is 618. If I want total volume, I'll just get, show totals. Okay. So total column volume is around 431 cubic meter. All right. So within a click of a button, you get the entire BOQ. You get the count, you get the size, you get on which floor it is, you get the level. So let's say this column is located in on floor number 5, you know. So yeah, 5.0 car parking number for floor 3. So with exactness of the details, you get the total. And for example, if you're, even the concrete grade is varying with the level of floors, you can see, So this is a greater advantage of getting the BOQ automatically if you use a BIM platform. Within just a few clicks here and there, you can get, whatsoever BOQs you want, right? Okay, guys, actually, yeah, I think I had today's intent was to showcase you some of the live projects. And if you have any questions, any queries, then I would be happy to answer. Hello.
Yes, sir. Actually, we have
Yes,
some
sir.
questions in Q&A, if you can answer that.
Sure.
Yeah.
Sorry, I was running a bit of short of time today. So are we having a Q&A sessions now, or we have a few other speakers as well?
If you are running out of time, it's okay. We can, the participants, they can share all their Q&As in the mail and we can answer that later.
Okay, fine. I also shared our mail ID.
Mm-hmm.
Please feel free to reach out to us if you have any queries.
All right. Thank you very much, sir, for sharing your valuable insight with us. I believe we all have gained something valuable to take forward in our work.
Okay, just a minute. Okay, I've seen the questions.
Mm-hmm.
Can we done generating electrical single line diagram also? From Vikram. So I think yes, if you are creating that in Revit, then you'll get the BOQ of the electrical as well. Okay. Slab and wall join, how you will connect, sir? Is that my detailed prepared in Revit? Yes. So the slab and wall connection is prepared in Revit, and then you can do the detailing. There is one option called as disallow join. If you want to do it in precast, you have to do that. Otherwise, in conventional casting setup, you just have to model in a traditional fashion. How to get shuttering BOQ? So if you get the surface area of all the elements, you get a shuttering BOQ, right? So you get the size of the columns, you get the size of the beams, slabs, you get the surface area of wherever you require. So some logic you have to apply some formulas and Revit. You create a template, and then automatically you can get a shuttering BOQ. So you have to create some sort of a template. It's a view template setting is there. So the way, let's say, you have to understand the logic, how you would, get, let's say, for a small example is for a column, if I need a shuttering BOQ, I would require the, surface area of all the 4 faces of column. So in that case, if I get the size of the column and if I get the height of the column, you write a formula and then you create a parameter that gives you the shuttering area of the column, right? So that's how you do it in Revit. Okay, then can you share more to learn from you? Can you share? Okay, from Rahit Bhatti. I've already given my mail ID, so feel free to get in touch and up to collaboration stage. So I think learning Revit is it's not a big thing. Like probably you just even some my lectures are there on Udemy. I've uploaded our lectures on Udemy. It's for a very minimal fee of I think 400. Anyone can go through the basics and up to the collaboration stage. One can learn that. Okay, so feel free to go to my Udemy course and learn Revit because. Then, as and when you work on live projects, you always have to do R&D and stay in touch with the latest tools and technologies. How important is naming and adding parameter type and family to make sorting and filtering easily? So probably this parameter is not everywhere required. Most of the parameters are system and inbuilt. Okay, and then I think if that does not solve your problem, and then you can always create a parameter. So creating a parameter is not a challenge, but you don't require it most of the times. I would say 15-20% on special cases you might require, but most of the parameters are there within the inbuilt system family. So same like you create like next question is how to calculate the paint area. So you calculate the surface area wherever you want to apply the paint. Then Revit gives you the surface area, and that is the paint area. So BOQ also you can add for the competition, because that helps you to analyze how cost effective the building is, number one, and then it also helps allows the user who is designing the building that on what budget and what BOQ he's being able to construct a built environment. So ultimately, it also boils down to sustainability and long-term durability aspects. So if you are able to save material and build at the same time, I mean that would be fantastic. So I think you can add in the competition, and that will help you analyze. Like along with the form and the shape of the building, what is the material savings and sustainability aspect to it. So that will also be good. Okay, so I hope I have answered all the questions so far. And then feel free to reach out to me. I have also shared our email ID. Thank you so much, everyone. Thank you so much.
Okay, yeah, let's end our session here. Okay, then until then, have a great day and thank you once again, sir.
Thank you. Thank you, everyone.